So here we have another problem. 2x minus 11 is less than or equal to 3, alright? So again, we want to get the x term by itself, so we need to get rid of this negative 11. So we add 11 to both sides. So what we'll have is 3 plus 11. Or if you want to do your usual stuff, negative 11. Cross is now positive 11. Okay, so we have 2x less than or equal to 14. And now again we want to isolate the x, so we divide both sides by what? Positive 2. Alright, so 2 into 2, that's 1, so we're left with just x. Now, do we change the direction of the inequality sign there? Yes or no? Remember, we only change it when dividing or multiplying both sides by a negative number, and therefore it need not to change. Alright, so 14 divided by 2, that's 7. So x is less than or equal to 7 would be our solution. And again, sometimes you're asked to show this on a number line. By the way, that is meant to be a straight line. Alright, so 0, and negative numbers go there. So 0, 1, 2, 3, 4, 5, 6, 7. Alright, so that's a number line. This is the number line, right? I know the number line continues and continues. Well, less than or equal to 7. So again, we use a full dot because less than x is less than or equal to 7. So x can be equal to 7. I will represent it like that. So less than 7 is 7 down, right? Less than, so good in the left direction. And if we're asked to use a set of integers to represent that set, less than or equal to 7, so it can be equal to 7 and it can be less. So the integers less than 7 or equal to 7 would be what? 7, 6, 5, 4, 3, 2, 1, 0, and so on. Alright? So this will be the solution set of integers if x is an integer. Alright? Let's look at another problem. So now here we have another problem. Now it's up to you to determine which side of the inequality you want to group the x terms, and that's totally up to you. It doesn't matter, it doesn't affect the solution. I will just stick to just grouping everything on all the x terms on the left hand side. So we have x, so we bring forward that, and by the way, x, just remember x is 1x, so let me just put 1x there deliberately. Just to remind when I'm doing it. And so on this 3x, we group, it becomes minus 3x. We bring forward the minus 9. Group with negative 3, we end up with positive 3. Good? So step 1, group like terms. Now, what's 1x take away 3x? 1 minus 3 is negative 2, so hence negative 2x. And negative 9 plus positive 3, well, negative 9 plus 3, that's what? Negative 6, good? So here now we need to isolate the x. We want the x by itself, so we need to divide both sides by minus 2. So minus 2 into itself is 1, anything, alright, so we have x. And then because we are dividing by a negative number, the direction of the sign change. And then remember when you're dividing, a negative number divided by a negative number give you a positive number. So x is greater than 3. And if we show this on a number line, so let's see, we start the number line at 0 there. And we have 1, 2, 3, 4, 5, and so on. Greater than 3. So we use a open circle there to represent greater than. So if it was r equal to, then we would shade and make it a full dot. But because it's greater than 3 means it does not include 3. X does not include 3. Alright? So that's how we show that on a number line. Here we have another problem. Negative 3 over 2x is less than 12. Now, just like solving equations, we want to get rid of the denominator. We want to get rid of the fraction. And how can we do that? Yes. Multiply both sides by multiply each term on both sides by the LCM. What's the LCM here? Well, the only denominator we have there is 2. The LCM is definitely 2. So 2 times each term. Alright? So 2 times minus, and then 2 times the other side. 2 times 12. And here's the whole point of multiplying by 2. Because 2 into 2 goes 1 time. So what you really have is 1 times minus 3x. So it's just minus 3x here. And that's the whole point of multiplying by 2. So you can get rid of the denominator there. And then 2 times 12, that's 24. So now we need to get rid of the minus 3, so we can isolate the x. And what do? Divide both sides by whatever you want to get rid of, which is negative 3. So negative 3 over itself gives us 1, so it's just 1x. And note, we are dividing both sides by a negative number. Hence, the sign change direction. So it's greater than minus 8. And that's our solution. Here's a final problem on this topic I want to work, at least for now. So, I know a lot of you probably just group the x's on the right hand side, which seems like a smart idea. And we can do that. Well, let me just group them on the left hand side and see what happens. And we can try it the other way. Let me just do here, just separate it. I'm going to group the x's on the left hand side here. The other question, I'll group it on the over here. I'll group it on the right hand side and examine what their answer is. So 9 minus x greater than or equal to 6x plus 2. So grouping the x's here. Don't forget, negative x is negative 1x. Just as how x is 1x, negative x is negative 1x. So grouping with 6x minus 6x. Here, bring forward positive 2. This is positive 9, so it's like we're subtracting 9 from both sides. So grouping this 9 over here, it's minus 9. Alright. So what's minus 1 minus 6? I don't keep the sign. So negative 7x. And 2 minus 9, that's minus 7. So we want to get rid of the minus 7. So we divide both sides by minus 7. Alright, so minus 7 over itself give us 1. So it's just 1x, which is just x. And because we're dividing both sides by a negative number, the sign change direction. Inequality sign change direction. And then minus 7 upon minus 7, negative divided by negative is 1. And also anything over itself is always 1. So x is less than or equal to 1. So use a full dot coming from 1 going to the left to show that on a number line. Let me do the same problem where I'm grouping now the x's on the right hand side. So if I'm grouping the x's on the right hand side, I already have 6x, so I bring forward that. Add x to both sides, so we're grouping with the negative x. So negative x is over here, positive x. And then on the left we have 9. And then to this 2, we subtract 2 from both sides. So the positive 2 group with the 9 over here is now minus 2. So 9 minus 2, that's 7. 6x plus x, well, 6x plus 1x, because x is 1x, that's 7x. And of course, the aim of the game here is to isolate the x, so we want to get rid of the 7. So we divide both sides by 7. Now, because we are dividing both sides by a positive number, does the direction of the sign change? No, it does not, because we're dividing by a positive number. It only changes when dividing or multiplying both sides by a negative number. So it's x. And 7 upon itself is 1. So the same solution. So x is less than or equal to 1. 1 is less than or equal to x. 1 is greater than or equal to x. Same solution. If we read it from, so let's show you something quickly. Alright. How would you read that? How would you read that? Two ways. You can say 7 is less than 1, or you could say 1 is greater than 7. The same principle apply here. X is less than or equal to 1, or you're reading here 1, well, x is less than or equal to 1, or you say 1 is greater than or equal to x. They are equivalent statements.